Well, let's take a little bit of time to talk about time. This is the time.h header. Again, part of the standard library. We include the time.h header when we need to manipulate time, or at least keep track of time. A little tough to manipulate it within our program. Here is a TM structure definition. This came straight out of my time.h header on my compiler, and it should look the same as yours if you're on the Windows platform. If you're on the Linux Unix platform, find your time.h and take a look, and you should have exactly the same struct layout, but you may have other information in the time.h a little different than what we have here. So this is our TM structure. Now this one is used for human timekeeping. I'm going to show you a piece of code I wrote here in a few minutes so that you can have an idea of how to use this and do some interesting things and put time and date into your program, possibly into your logs, and use it on reports, things like that. Notice that this structure has quite a few little values in it. Seconds after the current minute, minutes after the current hour, hours since midnight today. So that's basically military time, 24-hour clock time, day of the month, month since January, and so on down the list. So we're going to use that TM struct in a few minutes when we look at our time program. But that's one of the more important things that time.h sets up for us is this TM structure. Now there's also two different types defined by time.h. Clock T, the clock T type, is usually an unsigned long, but it is a value, a variable large enough to hold a number of clock cycles since the start of the program run. There's 1,000 cycles per second, at least in my system, and that will be implementation dependent, and it will be defined in time.h. Here, for example, if we want to time a simple program, we could pick up a start clock, create a variable called start clock, and it's of type clock T, and then somewhere in our code we would say that the start clock equals clock. That's the function, one of them defined in time.h, which will return the number of clock cycles since the start of our run. That goes into start clock. We do some work that we want to time, and there are much fancier ways to do this, of course, but we would do some work, and then we could say that the elapsed clocks equals the current time now, a few seconds later, or some period of time later, minus what time it was when we started, which would be a smaller number, and that gives us our elapsed clocks. You can divide that by the clocks per second macro, which is in the time.h, and find out how long it took your little piece of code to run. So that's one part of time.h. What we're normally more interested in is human time, day of week, minutes and hours and things like that. For that, we use the time t time value. This time value is a number of seconds since a date, usually 1/1900, something like that, and we don't really care about that number, but that number will be used to populate that TM structure that we saw before and get all the day of the week and the hours and the minutes and all of those things. So let's drop out of here and take a look at a piece of code.